right, our next presentation is titled RAFT, a resiliency framework helping North Carolina DOT prepare for future flood hazards with digital solutions by Kurt Golembeski and Garrett Shields. Kurt is a senior project engineer with North Carolina Department of Transportation, and Garrett is an assistant vice president at WSP USA, serving as the North Carolina GIS and development manager.
All right, well, thanks for coming out, everybody. The old adage still stays true. They put the fat guy right before dinner or a meal, so we're not gonna go over, y'all. We'll get out for dinner in plenty of time. But yeah, wanted to take some time and share with y'all some of the different resilience tools that NCDOT uses for both preparing for and reacting to disasters. I'm going to kick off and start a little bit, talk a little bit about RAFT and the system up front, and then I'll have Kurt kind of take over and give you the real good details on how DOT has been leveraging this. So we'll start out with just kind of where everything started. This presentation really is going to be kind of a tale of two storms. Some of y'all may have seen me present on RAFT before, so you may have seen these slides in the past, but to understand where we are now and how we're actually leveraging these applications, we kind of have to go back in time and look at the time before these existed, what prompted the development of these resilience applications, and that really was Hurricane Florence. During Florence, NCDOT Hydraulics that was their first foray into the emergency response. This was the first time they had ever been addressed and asked to take part in both the response and the actual emergency actions happening during the storm. It was not formalized, I think, at that point, but what happened was during one of the media events, press conferences during Hurricane Florence, DOT secretary at the time was asked a question by one of the members of the media on what roads the DOT knew were going to flood during Florence, and the secretary didn't have a good answer. And this was on I think it was a Saturday morning as the storm was going through. So the call kind of went out to the hydraulics unit and some of its consulting partners, just anybody they could get that could show up, essentially, that could get there safely to start trying to figure this out. They needed answers, and they needed it quickly. The next day, we spent the next 8 hours pouring through all the data we could possibly find, braving brownouts at DOT Century Center, trying to get to the storm. It's still happening outside. The storm it's still raining, the wind's still blowing. And at the time, during Florence, this was the best we could come up with. Now, this is kind of very similar to the maps you've seen that was put out during Helene for Western North Carolina, where they said, just don't go here. Well, this is really the best we could do at that moment in time during Florence. We had all this great data, but we couldn't put it together in a way that was specific and actionable. So we just kind of had to put out a blanket, don't go into the lower 2/3 of the state. And after that, we started looking at and realizing that, we've said it over and over again, and it's always been true that North Carolina is a very data-rich state. We have lots of data sets, lots of publicly available data sets, which is the big thing. We have statewide, the second largest DOT maintained road system in the country. Those road lines are publicly available. We have fully mapped LIDAR across the state. At USGS QO1, 8 points per square meter LIDAR statewide. The state floodplain mapping program has been working for the last 25 years to map almost as many flood hazards in the state as possible. We have floodplain boundaries. We've got a large state asset inventory of bridges and structures. And then we also now are starting to develop pluvial flood models, large-scale advisory flood models using 2D modeling. So all this data exists in North Carolina, is available to everybody. But at the time, in 2018, all those data sets were in various places. And you could get to them, but if you needed to get an answer quickly, it wasn't really conducive to getting an answer together very quickly. It was kind of clunky. You had to go download this, and you had to go over here and get some of this data, and then you had to go find the model. So it takes time. So what we decided with DOT after that, we had lots of discussions, lots of meetings, lots of great action items taken, lessons learned after Hurricane Florence was over with. And we spent the next couple of years kind of deciding, okay, how can we do better? That's been a running theme with everyone talking about with the Helene recovery or going back to Florence or Matthew or even all the way back to Hurricane Ivan is how can we improve? And that's one of the things that helps this state be the beacon that it is when it comes to geospatial, is that we are always looking to improve. So that's where the idea for RAFT kind of came along, was, along with a bunch of other systems that we'll gloss over and highlight, there's several applications the state has, primarily to help promote flood resiliency and emergency response. This is another one of those systems that does something a little bit differently, and we'll show later. But we wanted to take all of that great data that exists and pull it all together and put it into a system that allows a user, be it a DOT person or someone in emergency management, a local MPO or local emergency manager, to easily go in, pull up data, and leverage all of that great data to get to an actionable conclusion in a very short amount of time. So that was kind of where RAFT became, it's kind of the birthplace of RAFT, really. So what the heck is RAFT? And no, it's not a boat. Yes, it is, but not this one. RAFT stands for the Resilience Analysis Framework for Transportation. Essentially, what RAFT is, it is a web-based application framework that's hosted in the Amazon cloud. It's graciously hosted by NCEM on their AWS instance. You have a QR code here that you can take a picture of. If you want the website to get to RAFT, it's really easy. It's raft.nc.gov. Is a really simple URL to follow. And RAFT basically serves as a clearinghouse for resilience applications. Right now, it houses a couple applications that we've worked with NCDOT to build over the last few years, but it's ever evolving, and we'll kind of showcase here in a little bit some of what the future of this application is going to be. But it essentially allows you to go in and, like I said, leverage the data in a predictive sense, and start making decisions and start using this as a first step in your response and recovery efforts. So right now there are two applications in here, and I'll go over each one of them in a little bit more detail here in a minute. And hopefully there will be in the future some more applications that get linked to this site. I was talking to Kurt earlier about that. We want to integrate this more with some of the existing applications that DOT and EM have. So hopefully this list will get much bigger here in the future. But each of the applications that we built for RAFT are kind of unique in that we tried to make them as broadly user-friendly as possible. Not knowing long-term where they might live, who might be working on them, whose servers might be working, who might be hosting them in the future. We wanted to make the applications easily transferable. So we didn't really want to get bogged down in licensing and configurations and permissions and whatnot. So most of the architecture for the RAFT applications are really open source. We leverage a bunch of different systems. So we use AWS as our hosting mechanism in the cloud, but we're also using PostgreSQL for our database management system, PostGIS for the GIS, the spatial data hosting side of things. The applications themselves are coded using Leaflet, and then we're using Apache for our web server. Now I do have ArcGIS up here because you have to have Esri somewhere, right? So we used ArcGIS Pro to do all of the actual GIS analysis that built the data that went into the RAFT system. But once it left the data development side and went up into the systems, everything from that point on is open source. Even leveraging QGIS to an extent to do some nice raster processing and tile generation and try to augment some of the functions that we needed to get data built and serviced quickly that weren't necessarily available readily in an Esri product. So it was a very interesting build, very interesting build, very interesting architecture, putting all this together. So I'll go a little bit over some of the applications themselves. So the primary one and probably the most widely used application right now is the roadway inundation tool. We lovingly call it RIT. And it is a statewide application that will allow you to answer a few different questions. One, what roads might be impacted by an impending flood? What sections of roads might be impacted? How deep will the water be? And I don't want to know necessarily I can find out not only is this section of road going to be flooded, but how deep could it potentially be flooded? Because depth has a lot to do whether or not that road is passable or not. And then also a big one, especially down east, how many evacuation routes are going to be flooded? We've got a statewide evacuation route system for the eastern part of the state. What of those are going to be potentially impacted? And what this application leverages is the multi-frequency floodplain models that we have from NCEM, as well as the great LiDAR data that we have on top of the NCDOT road network. So quick rundown of the concept behind the roadway inundation analysis itself. And this is going to be the same concept for both applications that I showcase here in a second. So essentially what we're doing is we're taking the road networks and intersecting it with the maximum floodplain possible. So whether that section of road has a 500-year floodplain or a 0.2% annual chance floodplain available, or whether it's a 100-year, 1% annual chance floodplain, we're taking that and clipping it to the largest extent that has been mapped in that area. Now the state also, for most counties, there's still a couple counties, unfortunately, out west that are still lagging behind, but hopefully will be filled in soon. But most counties here in the state have what's called multi-frequency flood analysis. So we have water surface elevations, and we actually have flood boundaries for the 10-year, the 25-year, the 50, the 100, and the 500-year flood. So where those are available, this application takes advantage of that, and actually we ran the road network against all 5 of those recurrence intervals where they existed. And then what we did was we developed a point-based approach, which is a key difference in the RAFT applications from some of the other transportation planning tools and flood warning tools that exist. Because we wanted to have something that was measurement-based, individual measurement-based. And the big reason is clearly here, illustrated by some nice artwork, that roads aren't flat, they move. The terrain moves, sometimes extremely dramatically. And that changes the potential recurrence interval that affects a road. And that can sometimes happen in a very short amount of time, a very short distance. So we developed a point-based approach and took those road segments and clipped them down to every 50 feet. And that's where we took a measurement. Now, statewide right now, we are looking at having over 15,000 linear miles of roads have been analyzed against the state flood system. This is only going to get larger as we continue to work with DOT and EM as those flood hazards are refined, new areas are mapped. But right now, that includes over 1.5 million individual data points right now sitting in the RAFT system, which is pretty impressive. And what we actually found out was that statewide, about 10% of the road network is at some level of risk to flooding. Now, that might not seem like a lot, but when you consider, again, that North Carolina has the second largest road network in the country in terms of mileage, that's a lot of roads, and it doesn't take a very large section of road to be flooded. As many of you guys found out during Helene, a small section of road can cut off hundreds or thousands of people. So that's a big number for 10% of the road network to be vulnerable to floods. And there's a lot we still don't know, which is one of the great things about these applications and the analysis that you guys are doing, all the data that we're putting together as a state, is we're working to fill in those gaps. So this tool was first deployed back in 2020, and in 2021, 2023, I don't know my history. 2023, we actually added some additional data sets to the roadway inundation tool. We call it our version 2.0 upgrade. You've heard some people mentioning in various presentations the North Carolina advisory flood data. This is data that's produced using two-dimensional modeling methods, which I'm not an engineer, so I'm not going to try to describe what that actually means. But essentially, it's adding additional coverage and looking at additional flood extents, not just flooding around rivers and streams, but also pluvial flooding in areas of ponding, because it's looking at a rain-on-grid type model, so looking at actual effects from rainfall. So in 2023, we integrated the first advisory data set from NCEM, which was about 81 basins out in eastern North Carolina. And this added additional flood areas, you can see in the graphic, but also added additional recurrence intervals. So now we're starting to build up a new data set that includes a much larger coverage of flooding and also gives you more recurrence intervals to look at. And obviously, with storms like Helene, where several areas were estimated to have exceeded a 500-year event, more close to a 1,000-year event, once that data is available, being able to visualize it and quantify those damages digitally will be of great help. So moving on, the other application that we developed is what we call CRIS, our Coastal Roadway Inundation Simulator. So same basis of concept to the roadway inundation tool. The difference here is instead of using the FEMA floodplains, we're using basic coastal bathtub modeling. So we're looking at up to 17 levels of coastal inundation at 1 foot increments. We actually did the analysis and delivered DOT a data set up to 35 feet of flooding, which is, if you really want to scare yourself, look at what that is on the coast. But we stuck with 17 as the statistical maximum and built that out for our coastal counties. So basically it does the exact same thing as the roadway inundation tool, but we can actually move our slider up and down and visualize each of those different levels of inundation on the coast. And there's a couple of other functions that the CRIS tool has that make it unique. These are all proof of concepts right now. They do exist in the tool, so if you were to go log into RAFT and get into those, you could actually see this data, but it is still kind of proof of concept. One of the things that we've added in is some basic hindcasting. So we've taken some storms that already existed in the past. So Dorian, Isaias, Matthew, and Florence. We took those storms and took the National Hurricane Model data, the actual known flood elevations, coastal flood elevations from those storms, and we ran that against the existing road network to see what actually might have flooded. And we put that together into our coastal hindcast module, and from that we actually developed a concept risk rating. Now this is nothing right now, DOT's not using this mainstream at the moment. I'll caveat that because it is still very much proof of concept, but it's an interesting thing, so I want to just kind of go over it really quickly. Essentially what we're looking at here is developing a risk rating for roads. So you have a sample size of a certain number of storms. So in this particular one, we had 4 storms as our sample size. And we ran each of those storms against the coastal road network. And within those storms, we had 3 different levels of flood depth categories. So 0 to 5 feet, or 0 to half a foot to 2 feet, and over 2 feet. and we looked at every section of road to see what depth category that fell into. We look at that and then put it up against the number of storms that were impacted, and we developed a risk rating that kind of reads like 3-2 or 1-4. And what that essentially means is, for a section of road, if it was impacted by 1 storm, 2 storms, 3 storms, 4 storms, and then to what was the maximum level of depth that was impacted by any of those storms. So if one of those storms flooded that road up to 5 feet deep, that was a category 3 depth. So you might have a section of road that, it's kind of hard to see right here, but the purples and reds, these are the sections of roads that were impacted by the most number of storms to the highest level of depth. Now, why is that important? Because what that does is that gives us an area of priority. When we're looking at doing mitigation changes, or even during storms, what roads are going to be necessarily impacted either the earliest or the most frequent. Those areas that are impacted by the most storms to the highest depths, those are going to be the areas that emergency managers are going to want to prioritize when they're going out and doing road closures or checks, and those are also the areas that might be most prone for, ripe for mitigation, changes down the way. So that's a proof of concept, something hopefully we're going to be building out in the future as we kind of go through what's the future for RAFT. I'm going to highlight this really quickly, and then I'm going to turn it over to Kirk because he's got the really cool stuff to tell you. So right now we have a laundry list of things that we're planning on doing to RAFT in the future. Every time Kurt and I talk, we end up nerding out for like 30 minutes or more on, wouldn't it be cool if we could do this? And this would be really nice. And I love that, because everything that we come up with, whether it's based on new data that's available or an idea or feedback we get from one of you guys, is going to help this system. I'm not going to read through all of these, but I'll gloss over a couple. We are continuously making updates to the system. We're working with North Carolina Emergency Management as they're updating their flood studies. We're getting new flood studies, better modeling, more multi-frequency analysis. So we're working with them, and we're going to continuously update the data that's in the RAFT system so that it includes that new flooding. We're also going to be expanding the coverages of the North Carolina advisory flood data as that data becomes available from NCEM. They're kind of doing it in large river basin chunks right now, and I think that's scheduled to keep going on for the next few years still. So we're going to be working with them and the other consultants working on that to get that data pulled in. And some other things we're hoping to add are things like dynamic point-to-point routing. That's nothing new. Google can do that, but can Google route you around floods based on changing the flood scenario? So that's something that we're hoping to implement in the next version of RAFT, is to be able to have your scenario set and then get turn-by-turn directions from point A to B that route you around flooding if it's possible. And also we're planning a deeper integration with the FIMAN system. So FIMAN is the flood warning system that you've heard a lot about. If you don't know the FIMAN tool, you definitely need to know it and use it. We're hoping to get more deep integration into that moving forward. And then the big thing I'm really excited about is RAFT 3.0, which we are currently developing the draft of. Will it look like this? I have no idea. This was drawn by someone with meager ability, i.e. me. So it might look something like this, it might not, but we are currently putting together a brand new rewrite of RAFT. We're starting from the ground up. The idea is to make this a more user-friendly tool, consolidate both the CRIS and RIT modules into one single tool, and then add a bunch of that functionality, additional functionality that you saw on the previous slide. So we're hoping to have that out maybe sometime in 2026. We're working on the draft version this year, so stay tuned. By our next GIS conference in 2027, hopefully we will have even more to share with you there. But I'm going to go ahead and turn it over to Kurt, who will tell you actually how this tool gets used. So, Kurt.
I thought you said you're gonna have that done by the end of the year, not by 2026. But that's okay. That's okay. It's fine. No, I mean, I've been working with Garrett for 20 years, so it's always great to continue working with him, with WSP as well, and like the work they've done on this and the work they've done with floodplain mapping historically as well. So it's always a good time working with him and his crew over there at WSP. Hopefully it stays WSP for a while and doesn't go to AECOM or Wood or I don't know what's going on. All right, so enough of that. So flood warning tools. So here we go. So you talked about the RAFT. So that's planning. That's the bottom bit that we have here. And I'm just going to go over these real quick so you can see how they fit in. You've heard all about I think you've heard about firemen here and there as well. The other two that we kind of quietly keep to the side a little bit, but we use all the time is our surge analysis program called TSAP. That's an internal flood warning tool that we have related to the coast. And then Bridgewatch is a third-party vendor that provides it to us and many other DOTs as well. And that shows us what bridges would be impacted too, or roads as well. So I'll just cover each of those real quick so you just have a sense of like what we're up to during events, and then sort of what we're up to on sunny day or blue skies as well. And then how we responded and used these tools during Helene. And I'll get all that done by 4:55. Is that right? 5 minutes? Okay, no problem. All right, so flood tools. I just covered these three. Here's what they look like. We're going with dashboards on the GIS side of things. We're going to move into Experience Builder as well. But again, everything that you can see is starting to have that dashboard look. You got data on the left, you've got graphics on the right, you've got your widgets on the bottom, as it sort of is integrated. Bridgewatch is at the very bottom. They do their own thing for their in-house development, but they're very customizable to what we do. So firemen. We talked about that. You guys have heard about it. Moving on. Bridgewatch. Bridgewatch is great. It's essentially what its responsibility is, and I did have that one time. What that one is it allows for alerts to be sent out when our bridges are impacted, and it's either text alerts or email alerts at various thresholds. So for us, for bridges, is that we're concerned with like how high that water is getting up on the bridge, right? It's like, is it going into low steel, the bottom, the girder as you drive under it, or the water is traveling under it? Is it at that, and then is it above it, and is it overtopping? So Bridgewatch essentially, it monitors everything that is shown there. It pulls in slosh as well, so it pulls in surge, and it'll chart, track, and send us out alerts. TSAP, however, let me go back to TSAP. TSAP is what's happening on the coast. So what we pull in here is every time a flood advisory that you have on the left comes out from NOAA and the National Hurricane Center, we work with UNC. They run their coastal model called ADCIRC. Within like an hour, their data will show us taking the track, direction, wind, all that good stuff. Here's the inundation area at the coast. This is the maximum height it's meant to hit over the period of time of the next 3 to 4 days that the advisory covers. And oh, by the way, here are all the roads that are impacted as well. So it's a great, for us, and it's, again, it's model data, so it's not real world, but it's a good approximation that we can use for where our hot spots are. Are we talking New Bern? Are we talking Wilmington, for impacts? And essentially just here are our goals that I sort of mentioned in the areas that it touches on. It rolls it up all by division for us. It rolls it up by county, and it gives us, similar to the RIT tool, what we're looking for is, what roads, what type of roads, and then the depth on those roads. And then Bridgewatch, like I had mentioned, it pulls in, I think we have 16,000 structures that we pull in, and these are the alerts that we show as well. So just as I had mentioned, the freeboard, the gauge data, and then the overtopping. So that's it, and it can be used if you want to. It can be used for asset management. You now track how many times you've had a bridge that has had the water hit low chord. So we'll go out there and inspect them after an event too. That's exactly what we use it a lot for. Our inspection crews now know if we had, when Debbie came through, and Whiteville was hit pretty heavily, so we knew that's Columbus County. Now, rather than have our inspection crews head out to every bridge in Columbus County, we now, using Bridgewatch, we know which bridges had high water on them. So then they can go and say, hey, of these 200 in Columbus County, there's 81 that had it either low chord or above. So hit those first, and if there are other ones that you're aware of, you go to those second. So helps us be more efficient in recovery, and that's sort of part of the resilience side of things, right, is you prepare for, you respond to and you recover from, and you want to do all of those, especially the recover from, it bounce back as quickly as possible. So this tool helps us with that. And now on the RAFT front, so those are like just the overview, so you guys know sort of where RAFT fits in. Maybe heard of Feynman. You know about, we also have, DOT has surge and storm surge covered with our TSAP tool. Run that whenever a hurricane is on track. Actually, maybe behind the scenes, UNC is running this thing every day. But then the RAFT tool, how we used it, Garrett had mentioned it's a planning tool. Well, it's not just a planning tool. It could also be used operationally, and that's how we used it during Helene. And mainly, we knew for the Helene, the QPF, that's the NOAA version of this is how bad it's going to be over the next 48 hours. You may have seen one of these before, but this was, what do we have on the 25th? So keep in mind that Helene, really the worst it was on, that would have been a Wednesday there. The worst hit us on Friday morning on the 27th. It came through, and the main thing to check out here is, a lot of people deal with rainfall and depths with the hydrologists and hydrology. We're thinking, well, how bad is it? Like a barometer. Is it 200 year, 100 year? And that's what we map things to, so that's what we know. We're looking at 200 year, 500 year, right around that Asheville area, Grandfather Mountain, Mount Mitchell. So we know that's going to be bad, and that is about, like you heard Burnsville, Bakersville up north, there's Burnsville up there as well. You've got the base of the escarpments right here. So you've got your, French Broad River flows north, don't forget, it goes up through here and around, and then Chucky up north, the Canes here. So you've got all that is hitting right on top there. Similar, a little bit similar to Francis and Ivan, in its response, or Fred was out west a bit more a few years ago. So we knew it was going to be bad. So we used Bridgewatch and got an idea of well, how's it going to, for us, how bad is it going to hit our structures, our bridges? So I said, hey, let's look at it. Our team was like, let's normalize it to how many structures are impacted based on rainfall. So this gave us our hotspot of these are going to be the bad areas that we're going to have to be worried about, right? For bridges and washouts, what have you. So Buncombe County, Yancey, Mitchell, and that whole area in sort of the Asheville metropolitan area, if you will, could be impacted the most a couple days beforehand. So we all rolled up to got activated, went into the Joint Force headquarters. We've got DOT down in the basement. We've got the National Guard up high. That's our super awesome State Transportation Operations Center there. It's always neat. So when you see the messaging signs above, that's everyone in there is charting all that, the Drive-In C app. We're in a small conference room on your right, just trying to figure things out. And it's sort of, when we were looking through it, sort of came up with, well, where are hot spots, right? We know we're going to have a lot of rain. We don't know, it's above a 50-year storm is what it's looking like right now. Recognize that precip and runoff, rainfall and how much actually gets into the rivers aren't always like the same exact recurrence interval. But we had a 100-year rainfall event 2 days before Helene hit. So everything's saturated. You're gonna get 80% runoff rather than say 50 or 60% you'd get if it had been dry, if the soil had been dry and had absorbed that additional runoff. So we kind of turned to, well, we're looking at the interstate system mainly right now, where we are in Raleigh. Like, what could be impacted? We could look at the floodplain maps on Feynman, but we're just going to look at these small little snippets, and I'm going to have to go to each individual one, and it's not going to cover the whole county because Feynman picks up these areas around each gauge, right? Like 3 to 9 miles. I need to know, like on a county basis now, where they're going to be impacted. So thought, hey, we got the RAFT tool. I can look at my hotspots real quick. So essentially, I just start going through the counties, starting from like say I-77, Hickory, and you just work your way west. And you can click on each one, and you get this little table over here. And we were just looking for, well, when do we get this number? U.S. highways and interstates, for example, especially interstates. When is that number greater than 0? And Buncombe County was the winner, unfortunately, in that one. Really, that was about the only county. I-26 got inundated as well, south of Buncombe, and west of that, I-40 was pretty much in good shape from a river from being impacted by river flow inundating it. Along the gorge, that was washout from below on slope failure. So this sort of had us hone into this one area in Asheville and looked at. Sort of said, hold on a second, 40's never flooded in Asheville before that we know of. So this can't be right. Well, we had flooding currently occurring there, and this was what popped up was this area, this low spot right here. I said, hold on a second, this is kind of interesting. Let me give the guy, Chad Franklin, up in Buncombe County, who covers the whole area, a call and ask him, Chad, are you aware of this area? Has it ever flooded before? He thought I was crazy. He's like, Kurt, what are you talking about? What are you looking at? You're like, I'm looking at the RAFT tool. It's really cool. You know, it's showing the interstate inundated. He's like, Kurt, don't look at that. You know, like, what are you doing? I said, well, hold on a second, buddy. Like, we happen to have a gauge here in Feynman. So this is how we're sort of all trickling around the different tools we have. And it is showing the River Arch District is in a lot of trouble. You know, they're 1 to 2 days out. They're looking at 5, 6, 7 feet of water at the River Arch District. And this is from the forecast. It's coming from the Weather Service. So then we sort of trickled down there. It just so happened that fortunately, the inundation library in Feynman, it included 40. So it goes down here on the French Broad River, I think like right about here, right? 40 in that flooding area is there. So that's the area that we sort of looked at in more detail of what currently was happening. So in Amboy, flooding, as I was talking to him on the phone. And that sort of built up some confidence of, he's like, yeah, out there right now, it is flooding in Amboy, and you're showing it. So that's good. Like maybe in the future, I can believe you as well. Because like I hadn't talked to this guy before either, and he hadn't even heard of Feynman or the tools as well. So I'm like, I hope you believe me, and I hope the forecast is, I hope it's wrong, but you know, at the same time, it might be right. So we were looking at a couple days beforehand, and that's where that area popped out to show in Feynman. So again, that sort of came back. The RAFT tool, you know, showed us what was going on in that area, and this is what happened on 40. They sat out there, they closed it down beforehand. They didn't think the whole tool was so crazy afterwards when it sort of showed what was going to happen, and it did happen. So that's like, and that's where like the RAFT tool and the CRIS tool, you know, they can be used mainly for planning, and we do use them for planning. I'll talk about in a second. But you can sort of use it a bit. You can use it during events to get an idea of hot spots to be aware of, like almost like a flood advisory, you know, map of areas that are susceptible to flooding. Might not flood during this event, but you know they're susceptible to it. 10 through a 500-year event that you might not have known of before. So one of the things, so that's the RAFT tool, and I just wanted to show like a hodgepodge now of like what we're dealing, like an update on DOT, like what we're dealing with right now, what we've seen, what we're working on, and everything's actively. This might be the Cane or it might be the North Toe through here. This is what this project is starting up now for. We're doing all the modeling for it and the design. You got 19. Again, the road is completely washed out. The river is going down the bedrock, you know, where it might have been before we had the road there, and blasted out to carve that road along the hillside. You can see the stream channel is totally different. And we have, this one gets a lot of attention right now because this is going down on the way down to Chimney Rock. So again, the river is finding out where it wants to be. We're going back through there and building back in the road along US 74A 64, right there, Back Cave where it comes across the river. And then Burnsville up north here along I-197 is that we, again, we're just trying to figure out like where they talk about right-of-way. Again, you know, we have, our road is completely gone. You know, a question comes up, well, where's your right-of-way, DOT? You know, so that aspect from mapping and GIS portion of pulling at, having that right-of-way mapped and being prepared for the future. All right, so I'll finish up with one, and then I'll talk about a few more things at RAFT. Does anybody know what? So this is like mountain ingenuity out there. This is trying to figure out a quick solution with the materials you have on hand or that just show up on hand. So a lot of but some of the bridges, they needed something in fast. They couldn't wait for materials. They can't wait to rebuild it. We've got stone. We've got fill to bring in, but we need something to span the river. Well, out of nowhere, somebody dropped off a bunch of. Does anybody know what this is that's spanning our river now? Pardon me? Rail car? It is a rail car. It is a flatbed, flat rail car. They're all obsolete. They don't use them anymore. So we turned them in. They got that mountain ingenuity, man. They took those, they laid them out, put the approaches where they needed to. They welded on guardrails onto the top of them, paved them over, and that's our temporary bridge. If you're worried about it being able to carry your car, I think you'll be just fine, because they used to carry Abram tanks, and that's what they use them for the military. So I think we'll be okay with that. The last thing I just wanted to mention on the RAFT tool that Garrett had used, like what we're using the data for, is that we use it for like for communities. We use it for resilience studies on the planning side. A lot of communities will use that to develop the vulnerability and the criticality of a route. So part of the vulnerability says that we use is, what event is your road, or are your roads first impacted with flooding? You can pull that data from what WSP has developed. We use it for research as well. We have a pavement study going on right now, and they needed to know what areas of the county to go out to inspect pavement that is cyclically flooded. And so thanks to the RAFT tool, they sent out for each county to say they could pull that, and they could pull every area that the 10-year was flooded, and then they'd go talk to our county maintenance engineer and say, hey, these are the areas we think we need to go out and have a look at your pavement, see if it's been damaged. They're like, oh yeah, these ones are good, but I don't know about those. And they'd go out and say, oh yeah, we didn't really think about these. I'm glad you had this data. So that's one of the many uses. I can tell you guys more that we use the RAFT tools for as well. But we continue to find and leverage it. I know right now we just show roads on there, but one of the ideas are, we're just showing roads inundated. Why can't we work with communities to add additional structures, like your EOCs, your libraries, I don't know, your schools, or you can hire WSP to do that for you, and get your flood-prone areas mapped. Because all we need is a building footprint and an elevation of that first finish, the FFE, the first finished floor, and we could add it to this tool and sort of expand it beyond DOT, because it is a partnership with emergency management as well. So with that, we'll take any questions you might have. They're just.
If somebody in the room wants access to RAFT, can you elaborate the process to get access?
Yeah, so thank you. Thanks, Dan. RAFT is publicly facing. However, the one nuance to that is that you need a North Carolina ID, so an NCID, in order to access RAFT.
If somebody got NCID, it would let them in automatically once they authenticate.
Yeah. Because that. And the data is too. If you guys need the data, doing data sharing all the time with folks. So, yep. Thanks. Any other? Yes.
Does that work on local roads too, or is it state area roads?
We have both primaries, and so we have system and non-system roads in there. So right now, yeah, local roads will be in there all the way down. The only thing it won't be on is probably like private roads and that sort of thing.
Would that be a possibility in the future?
Possibly, yeah.
Mm-hmm.
Right now,
Yeah.
we're limited to where we have actual like classified road LiDAR. So when EM and its partners are doing the LiDAR acquisition, they're actually classifying it on the road and bridge decks. There's a certain limit to where they won't have the vendors classify those roads anymore. We can still pull ground elevation, but we need something a little more concrete to know that the elevation we're pulling is actually the road and not like a ditch or something else. So we could do it, it just might be a little bit less confident than we have like the LiDAR itself.
Yes, sir.
I'm wondering, I'm sure you've shown this off to federal DOT and to FEMA. Has there been any technology transfer of what you've done to them and from them to other local governments and state governments that might use tools like this?
Yeah, we've presented to them, and it's part of the technical. We're on committees with AASHTO and with FHWA as well, where they're aware of where they've been very interested in just learning about the various tools that we have, from Virginia, and we also just talk to other states as well, from Virginia to Texas, and make them aware of what we've done. So there is that aspect of the awareness, and then say, hey, if you want to reach out to any, we know the consultants to talk to. We're happy to talk to how we use it. But yes, there has been. like a couple years, what was it, a year or so ago, we talked at the Research Transportation Board's, like their extreme weather conference that they have every 2 years, that they invited us to speak at. Yep. Any other questions, comments? Where you guys going for dinner? All right. Thanks, everyone. Appreciate it.